In this video, we are going to learn what containers actually are, and we are going to do this by first taking a look at how we would deploy applications or websites or whatever we have historically. So firstly, we will take a look at bare metal, and then we will consider what a virtual machine is. And after that, we are going to take a look at how Docker and containers in general compare to these two alternative methods. And of course, we are going to review the benefits of containers over bare metal and virtual machines. And then finally, we are going to wrap up and review everything we have just learned. So let's go ahead and get started by answering the question, what are containers? Containers are isolated execution environments in which you can run your commands or deploy your environments or set up your applications. Now, before we explain how containers actually work, let's take a moment and look at how containers differ from the way we used to deploy things previously. So, if you have any sort of technical background or you are familiar with the IT concept, then you may be familiar with the concept of bare metal. And this is when you take your application and deploy it directly on the actual server itself. And if it helps, you can think of this as your workstation computer, the physical computer that you are on right now. It's the actual physical computer that's there, and for bare metal there is no virtualization at all. So bare metal basically just means that you have your hardware, you have your CPU, you have your RAM, you have your physical server, and then you deploy your operating system directly on top of that server. After that, on the operating system, you have all your prerequisite libraries and the things you need to deploy your application, and then you have your application itself, and it just sits on that computer and it's not isolated from anything else on that machine. Also, the major drawback to deploy the application using that approach is that the application's dependencies are engaged with the runtime environment. That means the application may be getting crashed when any updates or patches are applied to the base operating system. So then we moved away from bare metal and moved into the idea of virtual machines. And this is where we begin to start virtualizing things. And this basically means we take our actual physical hardware and we are going to use a program called a hypervisor to take that hardware and share it up between the different virtual machines. And each virtual machine will have its own operating system. And on that virtual machine, it will also contain its own libraries and its own version of the application. So this means if you need to scale, you will simply add more virtual machines. And while adding more virtual machines, that's going to be a lot easier than adding more physical servers in general. But it's still not a good solution when you want to deploy things quickly, and that's because it has to deploy the operating system itself as well as the prerequisites required for your application to work properly. And then finally we have our containers. And this is where we start to virtualize not just the hardware, but the operating system itself. So you are going to have your hardware, and of course you are going to have an operating system installed on top of that, just like in bare metal. Or of course, there is nothing stopping you from hosting containers on a virtual machine either. And then the container engine platform that sits on top of that operating system is going to leverage the existing kernel of that OS. So the container can run on top of that. Then when the containers are deployed, it has less to deploy. It doesn't have to deploy a full operating system. Instead, it will deploy the application and the prerequisites libraries needed by the application to make it run properly. So those libraries and that application stored in our containers are still fully isolated, and while they can talk to each other, it's going to be as though they were working over a private network, not as though they were two applications sitting on the same server, even they are technically sitting on two containers on the same server. Now let's move on and explain the benefits of container technology. Containers have a lot of benefits when it comes to comparing them to bare metal and virtual machines. Firstly, containers are quicker than virtual machines and bare metal servers. We already mentioned that when we deploy a container, it doesn't have to deploy that full operating system like virtual machines. And of course, you don't have to set up an actual physical server like bare metal. So instead, when you need to deploy something via a container, you can really save a lot of time when you use containers instead of waiting for a VM to provision. Secondly, containers are also very consistent. That means all of the libraries and application requirements are going to be packaged directly in the container. And ideally, when you have an application containerized, all you are going to need to do is share what's called a container image. And that container image is going to contain the application and its prerequisites required to make that application work properly. So once we deploy it, we are not going to have to actually go into the container and do anything. We are just going to have to run that container, and all of that configuration is going to be taken care of for us. Which also means if we share that container image with our friends, then they are going to be getting the exact same application that we have. So that consistency level is going to be really high, and that's going to solve a lot of potential issues that you can get when you hear people saying things like, well, it worked on my computer. Well, with containers, it's going to work on everyone's machine the exact same way. And then finally, deploying containers are simpler than deploying virtual machines. Now we already mentioned that when we deploy containers, these deploys are based on images, and these images contain everything we need. So no need to provision new VM with new OS to deploy our application. So to review, we know that containers are isolated execution environments, which is operating system level virtualization. So while they will contain their own operating system, they will still leverage resources from the underlying one. We know this means that our libraries and our applications will be isolated in a namespace, even if some of our resources are shared, and that containers are faster to deploy and use few resources than more traditional methods such as bare metal or using virtual machines. That's to conclude our session. See you next video.